This is ADAR that we have launched.
Okay.
And, last year we have more than 20 global testers who tested the evaluation kit. And they have given us feedback. One of the feedbacks is that the form factor we have on the evaluation kit will have to be a lot more slimmer like this.
Okay.
So that they can go onto a low profile AMRs.
Yeah.
And you can either put it on AMR from the outside or you can flush mount it as well. And then you will be seeing just essentially this surface.
Okay.
Yep.
And this is the form factor from
The evaluation kit.
the evaluation kit. Okay. It's still surprisingly compact.
Yes.
Yeah. I'm used to ultrasound as a grandparent looking at my future grandchildren, so.
Right. But this is also another advantage because, it's going to be so small that, it doesn't jeopardize the aesthetic of the AMRs.
Yeah.
You can integrate it and, design flexibility in that sense instead of like a big chunky 2D LIDARs, for example.
Yeah. Can you use that to navigate like the first time around? Let's say you have a factory floor and you want your AMR to navigate through the whole thing. This will help you with obstacles, right?
Yeah.
For people.
Yeah.
Is there a separate navigation?
Yes.
Okay.
So you can use a non-safe LIDAR for navigation. You can also consider a sensor package that fused with a V-SLAM.
Okay.
Yeah, so you can use V-SLAM for the navigation.
Yeah. Okay. Good.
Yes.
All right. So, but this is the purpose here is people are going to be safe
Yes.
with that on the AMR.
Yeah. But it's not just people. A lot of the customers who are using AMRs, they are saying that they also want to make sure, one thing is of course no accidents, but sometimes they're carrying very expensive materials, right?
Yeah, that's
And
true.
they don't-
Titanium.
Yeah, exactly. So they don't want things to be broken as well.
Yeah. No, that's right.
Yes.
You can talk to any vendor, right, to include that in
Yes.
their safety pack.
Yeah.
So, when do you think a product might come out? I'm not going to pin you down to this.
Sorry. What do you think?
When might a product come out usable on the market?
Oh, so this one we have launched last week.
Oh, all right.
Yeah, but shipping is from July.
Okay.
Yeah, so it will
Not long.
come with safety certifiable hardware, so it's already available for use.
Great.
Yeah, and we have customers who have ordered, so they will be
All right.
designing it in, and we are very excited.
Good.
Some are even implementing it with their next generation of robots in the next few months, so we're looking forward to that. Yeah.
I don't see anyone else working on that technology.
No, this technology is based on 20 years of research on MEMS.
Yeah.
And we have a global exclusive license to that. So the technology is actually very unique because the MEMS technology enables to string the transducer to a very small size so that you can space like half a wavelength apart from each other to apply this beam forming in air. So you get this 3D view. And then we coupled it with our proprietary signal processing algorithms. So it's patented technology. Yeah. So it's not something that you just
No, I know, and in
put it
fact,
out in the market. Yeah.
one of the robot makers, Sear, they're down here. They have here's all the stuff that's inside of our AMR,
Right.
and a lot of it is safety. A lot
Yes.
of it's safety driven.
Yeah. Because there's also a list of safety components that AMR manufacturer will reference it to in order to get the level of safety certification
You have
that
to.
they
You
can
have
get.
a choice.
So the better the performance level of the safety components, the better chance that they can get a higher rating for their performance level of the robot as well. So it has a correlation to that.
Yeah,
That's why we
now
are.
you can get into maybe aerospace or things
Yeah.
like that.
Yes. But we start with robots, and there are many opportunities, of autonomous moving robots. So, yeah.
Good.
Yes.
Well, thank you so much.
Welcome. Yeah.
Here in Sonair, we developed the first safe 3D ultrasonic sensor. We actually just launched our first product last week. End of this year, this will also be safety certified to SEAL2 PLD. and it will be the first safety certified 3D ultrasonic sensor. So that's
Wow.
pretty cool.
That is cool.
The core IP of the company is the transducers that we're making, or it's based on research from 20 years ago, and we are now using these transducers to emit out ultrasound that's sent out of the sensor, hits an object, it's reflected back to the sensor, and based on the time of flight and the angle of the receiving wave, we can tell not only the distance to the object, but also where the object is located in space.
Okay.
So I can show you just a bit here now. Just imagine, first of all, this is our evaluation kit that
Oh, yeah.
customers have been testing for a couple of months
Okay.
and giving us feedback, and basically just led to this product here with all the features that the customer
Sure.
wants. So imagine an AMR driving around the warehouse, needs to know, is there a human or a dangerous object in front of it that it has to stop for? Really important for safety for people, but also not damaging things around and the AMR itself. So what we see here is, first of all, I've divided the region of interest to only look at this table. We actually have 5 meter range, 180 by 180 degrees field of view.
Oh, wow. Okay. Yeah.
So that's pretty cool. What we see here now, if I take this one out, we see the red light goes off. That means, okay, the AMR is now safe to go. As soon as there's an object there, the red light goes on and
Right.
it has to stop.
Yeah. So that's pretty responsive. I
It's
mean,
pretty responsive.
sub-second response.
Yeah, we got 100 milliseconds latency.
Wow. Wow.
What's cool about this is, you know, the typical AMRs use these 2D safety certified LIDARs.
Right.
However, this is a 3D safety certified ultrasonic sensor. That means that we are not only seeing in 2D, but also in 3D. So if I take my hand in here now, you see the light is
That's
going.
not a lot of latency there. That's great.
Exactly,
Yeah.
that's pretty cool. So that's our like main. We're outputting our this safety function, but we're also outputting. So what we see on the screen here, we see a single
Is
dot.
this your control and management software here?
Yeah, so this is basically just a visualization of the point cloud that comes
okay,
out of the
yeah.
sensor. We now see a single dot there. That's the same object that we saw here on the
yeah,
table.
sure.
If I move it over, you see that now it's outside that red dangerous zone.
Let me back up and do that again if you would, so that we can see it on the screen.
So now we see the object as one single point here. It's outside that red rectangle or outside this dangerous zone. If it's inside, you see it now move into that red rectangle,
Okay.
and the LED goes on, and the robot has to stop.
Cool. Okay.
And yeah, as we saw when I took my arm in here, now we can see that my arm being detected in and out of the stop zone.
Oh, I see. Yeah,
This
yeah.
shows the 180 degrees vertical field of view as well.
Wow. Okay. Yeah, do get that too. Wonderful. Okay.
And not only that, typical LIDARs, laser scanners, they struggle with transparent objects.
Oh, yeah.
But
sure.
transparency and transparent material is not an issue for ultrasonic sensors. Actually,
No,
almost all
it just needs a
materials.
surface, right?
Exactly. And almost all materials look solid to us, even like these typical foams and such like that.
Wow.
That's because we're so high in frequency that the bandwidth, the wavelength is so small.
It actually gets it skips the whole part and gets that tiny little part
Exactly.
of the foam, right?
Exactly.
Yeah. Wow.
So that's pretty cool.
That is really cool.